Given a sine function, voltage versus time in seconds, expressed as a cosine function. It's okay because sine equals cosine, shifted 90 degrees. Given V1 is 20 volts, V2 is negative 20 volts, and V3 is 4.52 volts, and the period is 7.6 milliseconds. Find Vm and omega and T3 and theta and the voltage shift. Most of these are obvious. The amplitude is 20, theta is negative 90 degrees, and the vertical shift is 0. Omega is calculated 2 pi divided by the period. But T3 is not easy. So solve for T3. Substituting known values into our equation, we know the voltage, we know the amplitude, we know the phase shift, we know omega, stored in the calculator. We know everything in this equation except t, which is T3. One equation and one unknown. T3 sounds easy. Let's solve it using basic algebra. Divide both sides of the equation by 20. Take the arc cosine of both sides, add pi over 2, divide by omega, and there's 3.52 milliseconds. What's wrong with 3.52 milliseconds? 3.52 milliseconds is an answer, but it's not T3. There are an infinite number of values of time for the voltage 4.52 volts. There are 4 of them. 3.52 milliseconds is here. How do we know it's there? Well, we know because we know the period, we know half the period, we know quarter of the period, and so that puts 3.52 milliseconds relative to half of a period right there. So T3 can now be calculated due to the symmetry of the sine wave. There is another way. The calculator can solve it. Enter that equation into the solve function. The value of omega has been stored into the variable w. T is the only unknown. And here are the possible answers. At n some number is an integer. Here are 6 values of t for the integers 0, 1, and 2. There's one value. There's another. There's another. The other 2 are not shown. Make sure your final answer has 3 significant figures.